Okay, hello again. We're back to probably look at some topics that could come up on the final exam and some things that we, in our, at least in our school, we kind of overlooked and we're hoping that it doesn't show up. So first, this number one, if we look at this, expressing geometric properties with equations, what I did was I just clipped the Common Core curriculum. And what's going to happen is we're going to derive the equation of a circle given the center and radius using Pythagorean theorem. Now, I'll show you what we have normally done, and then I'll show you the adjustment that would need to be made if they made it a four-pointer where you had to kind of explain. Okay, so it's going to kind of be twofold. All right, so taking a look at this right here, this equation of the circle, I'm going to start out with, if you are given this on a part one question, it's really simple. We're going to use the memorized format. Okay, so we've got this memorized, um, this center radius form. Okay, and what we're saying is HK would be the center, and R is the radius. Okay, so really simply, if it's a part one question and you have to look at the choices, you just have to know it's X. We take the coordinates of the center. Okay, we're going to actually call it X minus 3 squared, which some students get confused by. I'll explain in a little bit. It is always the opposite sign, basically, of what that number is. Okay, that's the X coordinate, and it's going to have to be X minus 3 squared plus, and again, we have this weird concept of Y minus 1 squared. The radius, if you count it, if it hits perfectly, you can simply count it. If it didn't, let's say it didn't hit perfectly, you'd have to figure out a point and then use Pythagorean theorem or distance formula. This does happen to be a nice 5, so don't forget to square it. Okay, so you're going to get X minus 3 squared plus Y minus 1 squared equals 25. Now your choices are going to be with plus signs in here, and instead of 25, it'll be 5 or maybe 10, doubling it. So they'll try to throw some decent distractors at you. Make sure that we really stay focused on this one. It's a problem that we can't miss. It's a part one. All right, now, if it's an open response, such as a four-pointer, remember, four-point open response questions take a lot more than your typical questions. So if they are in a four-point mode for this question, they're asking you to derive the equation, using the distance formula or Pythagorean theorem or whatever. Now, how that's going to work is you see this random point xy. Now, we can actually figure out what it is on this one, but let's assume for a minute that maybe it was not on a nice intersection. Okay, here's what we would have to do. They would tell us the center. Okay, the center they would give us is 3, 1. And they'd also tell us what the radius is, whatever it is. In this case, it is 5. Okay, now, here's what you're going to understand. The distance from here to here has to be 5. Simple. But we have to develop an equation for any random point xy. Okay, we have to develop this. And how you're going to do it is you're going to basically perform a Pythagorean theorem problem. Okay, you know the hypotenuse is 5. Okay, we're going to use, all right, a squared plus b squared equals c squared. Okay, the leg squared plus the leg squared equals the hypotenuse squared. Now, what is A? Well, A is the distance from the center out to this x value. Okay, so A is the change in x, okay, and that change in x can be written as x minus 3. All right, now the B that we're looking at, it's going to be the change in y, and that is y take away 1. So now we're going to substitute in right there. All right, sub in. So instead of a, we're going to sub in x minus 3. And then we got to square it. Plus, y minus 1 is the substitution for b, but then we got to square it, and equals 5 squared. So that is how you would develop or derive that equation. Okay, and let's just rewrite it and finish it here. And along the way, you'd have to explain that. Okay, so kind of mention some things like Pythagorean theorem. Okay, you have your graph right here, so that shows some of the work. Okay, a squared plus b squared equals c squared. You wrote that down. And now you're also showing some substitutions, kind of explaining what's going on there. Okay, so hopefully that would be enough for the 4 points. That's the type of problem that you could face if they decided to. It's really doubtful. They never have before. The reason I'm doing this is just in case this is something that they decide to kind of trip you up with. Basically, these are the topics that if you're going for 100, you might want to look at this in case this comes up. All right. Now, the other one, complete the square, that has come up several times. So I'll show you an example of that. Okay. Again, we want to get an equation in this format. X minus h squared plus y minus k squared equals r squared. That's that center radius format. Now, the equation they're going to start out giving you is as follows. Let me just go get that. Let's see. Okay, so they gave us, let's say, x squared plus 2x plus y squared minus 10y plus 6 equals 29. Now, a quick version of the lesson on this was I did a whole bunch of these problems, like x plus 4 squared, with my students. And I showed them that when you square a binomial, you can't just say it's x squared plus 16. You can't distribute a squared over addition. That's just not how it works. What you do is, squared means there's two of these multiplied together, and this is a double distributive property. So you don't have to write this out. I'm sure you have shortcuts for this, but I say x times the whole thing, x plus 4, plus 4 times the whole thing, x plus 4. Now that's the first distributive. Now I'm going to distribute again. X times x is x squared plus 4x, and then we're going to distribute that plus 4x plus 16. So notice, here's the key. Oops. This is something that a lot of students forget, that middle term. All right, I'm just going to show you one more. So let's say we had x minus 3 squared. If you've memorized the pattern after about 7 or 8 of these, you'll start memorizing. You'll see, without even doing any work, you'll get this pattern down. When you square a binomial, okay, what you're going to have is, you're going to have that term squared. You're going to have negative 3 squared is positive 9. Make sure that's positive. And then what you're going to get is 2 of these negative 3x terms in the middle, and that's where you get negative 6x from. So if you do enough of these squares to memorize that pattern, all right, one more time, just pause for a second and think. Without any work, you should be able to multiply this out right in your head. Good. So it should come out x squared minus plus 10x, plus 25. Okay? So that's, once you get to the point where you can do this in your head without much thinking, you're ready for a problem like this. Okay? But we got to make sure we have this skill down first, all right, this math fluency down before we get back to here, because this whole thing depends on this knowledge. Let me show you. So what's going to happen here is, first, I want to get to x minus h squared, so to speak. I'm missing a term. So here's what I like to do, is I like to write down x squared plus 2x plus some number that will complete that square. And I'll show you in a minute. We'll come back to it. Now we're going to go to plus y squared minus 10y plus, again, something to complete the square. I keep the 6, I keep the 29, keep the equals, and then I recognize that if I'm going to add something to the left side, I better keep it balanced, right? It's an equation, so let's keep it balanced. If I add something here, I'm going to add something to the other side to balance. Same thing right there. So I'm going to add two numbers to the left, so I'm going to have to add the same two numbers to the right. Now, here's where this comes into play. If you've memorized this pattern, you see this middle term is always twice what that is. That's if the lead coefficient, of course, is 1. It gets into a whole nother mess if that lead coefficient is not 1. Okay? So let's assume for a minute that it is a lead coefficient of 1, which this is. Basically, you're going to cut that in half, and that's what's going to be squared. Now, what number belongs here that would have completed that square? Well, 1 squared is 1. So if you add that to the left, you got to add it to the right. All right, same thing. These three are going to combine to get us, again, cut that in half, -5. -5 squared is +25. It's always a positive when you square a number, unless you're in complex numbers, which is something different. Okay, so now 29 plus 1 plus 25 is 55. And last step here is I would subtract 6 from both sides. Okay, now we've seen this a bunch in our class. We have seen it come up on the exam quite a few times. If you need to get the center and radius from there, it's pretty easy. Don't forget, the center is always the opposite sign of what's in the parentheses, so it's -1, +5. And the radius, don't forget, it's the square root of whatever that number is. Okay? So that is pretty typical, that question right there. You can bet that that's going to be on there. Okay? It could be a part 1 question. It could be an open response. We don't know, but it's usually on there. Now, I'm going to get into something that we have not talked about at all at least in my classes. Okay, I'm not sure if the other teachers at Hilton have taught this or not, but it's derive the equation of a parabola given the focus and directrix. It is in the curriculum. What that means is it could be on the final exam. We've skipped it. I would say continue to skip it and stop the video if you're not shooting for 100. Okay? It is very confusing, complex, but those that are shooting for 100, we're going to cover it to make sure that nothing is missed in the curriculum. Okay? All right, so here goes. First, I should tell you what a parabola is. What you know from parabolas from algebra is you may have had them, I don't know, I'm just going to make one up. This parabola right, that would form a parabola. This right here would form a parabola. Its roots wouldn't be very good, but it wouldn't be on nice numbers, but yes, you would have a parabola there. So, actually, it would be imaginary. But again, it's of this shape. Okay, when you graph these, you knew it was some kind of shape like that. Okay, probably never got into the geometry or the definition of it or anything, and that's what we've got to get into today to be able to derive the equation of it. Another format for parabola is in vertex form, where you might get something like this. That would give you the vertex of 3. Again, it's always opposite of what's inside. Be 3, 4. And then you could graph it using a pattern, whatever. All right. Now we're changing. This is from last year. You'd probably make your table, graph, all that good stuff. We can still do that. Okay. That still could come up this year. All right. To advance, if we want, again, a 4-point question, if we have to derive the equation, derive it, given the focus and the directrix. First, I've got to tell you what's going on with all this. Okay. This is why we skipped it. Just incredible. So, the definition for parabola in terms of locus, of points, it's the collection of all points, all right, that are equidistant, means the same distance, equidistant from a point and a line. Now that gets really weird, okay? I'm going to try to sketch it. Hopefully it's not too awful. So what they'll do is they'll give us a point, which we call a focus. Then they'll give us a line, which we call a directrix. Now what we're supposed to do is find all the points that are the same distance from both. Now the first point that we would find is very intuitive, okay, but the rest are not. I would draw a perpendicular line through the focus and I would find the center of it. Okay, it's that simple. So this distance at a right angle with the directrix, let's say that's 5. Well, then from the focus to this point would also be 5. Now, what I'm saying is that's one point that is equidistant from the focus and the directrix. And what this will be is the vertex of our parabola. From there, it gets kind of tricky. Okay, I'm going to try to sketch a parabola that is going to work, and I'm probably way off, but I'm going to do my best. And what you're going to notice is, if you remember, right, parabolas are symmetric, and the line of symmetry goes through the vertex. Now, here's the other part of it. The axis of symmetry is also perpendicular to the directrix. This is that's something new that you didn't know. So this is your axis of symmetry, meaning both sides of this parabola are identical, symmetric. Okay. Now, here's where it gets tricky. If this point is truly on the parabola, it has to be equidistant from the point, the focus, and the line, the directrix. So here's what I'm suggesting, okay, for a minute. Let me just try a different color. I'm suggesting that this distance right here from the focus to that point is identical to that distance from the point to the line. All right, looks pretty good. It's unusual that I came that close by sketching, but yes, that looks like it's decent. So what I'm saying is, let's say maybe this is 9, right? Well, then from here to here is also 9. Okay, so let's try another one. What are we saying? Well, let's go out to here. Okay, the distance from this focus to here must be identical as here to the directrix. Now you keep seeing I draw a right angle. The quickest distance from a point to a line, you have to make a right angle with a line. Okay, any other angle, it's going to go further. That's the quickest distance from a point to a line. Let's say this is 13. I'm just going to make that up. I don't know if it is or not, but 13. Well, then from the focus to that point is also 13. Okay, so that's what we're saying. That's the idea or the concept behind a parabola. It's all the points that are the same distance from this directrix or line as it is from the focus or the point. With that in mind, we're going to try to derive the equation of a parabola. Now, when they do that, I'm really hoping that we only work with the directrix that's a y equals line, or maybe even an x equals line. It would be kind of crazy, but let's assume for a minute that we're going to work with one that it's a y equals line. All right, so we'll come down here. We'll show you an example. Okay, what I did was I actually made an example on Geometry Sketchpad of a parabola right here. This is the parabola. What that means is this is the collection of all points that are supposed to be the same distance from this focus as they are from this directrix. Okay? Now, they'll give us the focus location. In this case, it's 2, 3. They'll give us the directrix equation. In this case, it's y equals -5. Okay? And we will have to come up with the equation, derive the equation using Pythagorean theorem. Now let me just take a random point right here. Okay, it's not a good location. I'm doing that on purpose. I'm going to name that point xy. It's a random point on the parabola, right? Here's the concept. The distance from here to here must be identical as that distance. Now it doesn't look it right now. Could have been a stretch graph, I don't know. But this, if it's the right parabola and the right focus and directrix, these amounts are going to be identical. Okay? How are we going to prove it? All right. Well, what we're going to do is we're going to come down here and we're going to use Pythagorean theorem. The distance from the focus to some random point, we can use x and y for this random point. It's going to be the change in y there and the change in x. We're going to use Pythagorean theorem. Okay, we're going to call this the distance from the focus to the point that we're talking about. All right, so all of this is work that's got to be shown. Now, what I'm going to use is, again, Pythagorean theorem. A squared plus b squared equals c squared. Okay, I am, kind of letting the person grading my paper know that's what I'm using. Okay, and what I'm going to have is a is going to be the change in x. Okay, b is going to be the change in y. And c is going to be d squared. Okay, so this is just kind of like substitution. All right, also, something I'm going to look at. The change in x is actually, however far that is. Well, that's x. And over here is x is 2, right? So what we're going to do is the distance between these is x minus 2. The change in y is going to be the distance from 3 down to wherever y is, right? I don't care if it's positive or negative. What's going to happen is I'm going to call it y minus 3. 3 minus y, it won't make any difference because we're going to square it. So now we're going to substitute in again. Instead of changing x, I'm going to call it x minus 2. Okay? And in changing y, I'm going to substitute in y minus 3. All right. That's, again, substitution. Right? Next, this is going to get kind of crazy here. This should be the same as this. So I have a replacement for d squared. Okay? D is this amount right here, whatever it is, but it's also equivalent to that. Now that is straight up and down, which is why, it's pretty reasonable for us to do this. It'd be crazy if they give us some other line, and they can't. This is hard enough as it is, so there's no way they'd give us some other line other than a y equals line. But here's what it looks like. So this distance is actually going to be y take away negative 5, which is y plus 5. So let's come down here. I'm going to need a lot of room to work with this. Sorry. It's x minus 2 squared plus y minus 3 squared. And what we're going to do is we're going to take that y, it's really y plus 5. Y minus negative 5 is going to replace d squared. So it's y plus 5 squared. Now, after doing this, I'm going to leave this alone. Okay? I'm going to leave that. What I'm going to do is I'm going to mess around with the algebra here. Okay? So I'm going to double distribute that. Remember from before, we have to know what that is without even thinking. So it's y squared minus 6y plus 9. This is y squared plus 10y plus 25. I'm going to leave this alone, and you'll see why in a little bit. Okay? What we're going to do next is we're going to subtract y squared. We're going to take all this stuff and move it over there. So we're going to subtract y squared. We're going to add 6y. We're going to subtract 9. Keep that even. Subtract y squared, add 6y, subtract 9. I probably don't have to do that, but I'm going to do it anyway. So that's all gone, right? And over here on this side, it's x minus 2 squared. That's gone. 16y plus 16. Okay. I got an idea. So why don't we factor out a 16? This is one way to go, I guess. And divide by 16. All right, I'm going to change this to 1/16 quantity x minus 2 squared equals y plus 1. You're seeing that it is the format of a parabola. If we rearrange some stuff here, I'm going to switch these two sides here. I like putting it over here. Subtract 1. So it looks like we have this. -1. Yeah. So what we just did was we derived the equation of this parabola using Pythagorean theorem and some pretty advanced knowledge of parabolas, that they're equidistant from both a point and a line. Okay, so a squared plus b squared equals c squared. Right, I replace c squared with this squared because these are the same. So that's all substitution. All right, get down here. This is the equation of a parabola in vertex form. The vertex is going to be, it looks like 2, -1. Let's go verify that up here. If you look, there is the vertex at 2, -1. And then that 1/16 is flattening it out pretty good. And that's the equation. That's how to derive the equation of a parabola. Now you can imagine why we skipped that this year. We've never seen it before on an exam, but that doesn't mean it's not good math. We still should know what we're doing on it. I think the biggest concept is knowing this, okay? Equidistant from a point in a line is something that's critical. So that's it for this session. If you're shooting for 100, you might want to try a couple of these. Feel free to message me. I can make up another one. These are pretty tough to make up ones that work nicely, so you're going to need some help with that. Again, feel free to send me a message. Let's see, where were we? Okay, now this, derive equations of ellipses and hyperbolas, given foci. Okay, that's got a plus sign. It's not supposed to be for this exam, but the New York State Regents has put on plus signs before. Has put on content that's had a plus sign in front of it on the exam, but they'll talk you through it. So it's going to end up being an investigative task if they do. And I'm not going to gamble and try to scare you for that concept. So do the best you can if that comes up. And, hopefully this is helpful. And I'm looking forward to seeing how you do on the final. Take care.